Now we're going to look at the standard error of the mean, that is, of using the sample mean as a method of estimating the population mean, is the standard deviation of those sample means all over possible samples of a given size drawn from the population. There will be less dispersion in the sampling distribution of the sample mean than in the population. As the sample size increases, the standard deviation of the mean decreases. The standard error of the mean, which is denoted by sigma sub x bar, is computed by dividing the standard deviation, sigma, by the square root of the sample size n. This is one of the essential elements of the central limit theorem. In computing probabilities using the sampling distribution of the mean, there are two common distributions, the z-distribution and the t-distribution, that are used. We use the z-distribution, otherwise known as the standard normal distribution, if the population standard deviation is known and the population is assumed to be normal. If the population is not normally distributed, but the sample contains at least 30 observations, the central limit theorem guarantees the sampling distribution of the mean to follow a normal distribution. On the side is the formula for computing the z-score for a given sample mean. We use this formula to determine the probability a sample mean falls within a particular range. The numerator of the z formula is the sampling error of the sample mean. The denominator is the standard error of the sample mean. Once a sample mean is converted into a standardized z-score, we can determine its probability using the procedures we learned in Chapter 7. We'll show you how to do this on the next few slides. If the population standard deviation is not known, and if we know the sample comes from a normal distribution, the t-distribution is appropriate to use. If the sample size is larger than 30, then the normal distribution assumption is not necessary because of the central limit theorem. Similar to the formula for the z-distribution we saw in the previous slide, the numerator of the t formula is the sampling error of the sample mean. The denominator is the standard error of the sample mean. The only difference between the z and the t formulas is the standard deviation used in the denominator. So for the z formula, we use the population standard deviation since it is known, whereas in the t formula, we use the sample standard deviation in lieu of the population standard deviation since it's not known.